So the first thing we're going to do is take this function and find the first derivative. So as we're looking at the first derivative, we want to go ahead and let this portion be u, and then e to the negative x will be v. So for u is equal to x to the fourth, the derivative of that is just 4x to the third. And then for v equaling e to the negative x, the derivative of that is just itself, which is going to be e to the negative x. But we have to remember that whatever our exponent is up here, I have to take the derivative and multiply that. That's the chain rule. So that's going to be -1. All right, so once we have that, I can go ahead and put all that together. So my first derivative is going to be x to the fourth times e to the negative x times -1. Or I can go ahead and just write that as negative e to the negative x times x to the fourth. Now I need to go ahead and do the second part of the product rule. Now I do the second part of the product rule, and I am left with 4x to the third times e to the negative x. Now, what the first derivative test asks us to do is take that first derivative and set it equal to 0 and solve it. In order for us to do that, I have to factor this out. I have a greatest common factor of e to the x in both. So I'm going to go ahead and pull that out. And then the other common factor I have, if I go ahead and look at x to the fourth and x to the third, I take the lower of those two, which will be x to the third. And now I am left with, on the inside, -x plus 4. Now that it's all factored and all of these are in the terms of product, I can go ahead and look and set each of those factors equal to 0 and solve for x. Now for the first one that I have here, e to the negative x, that's never going to be equal to 0. So that one doesn't get included. The next two just gives me a value of x is equal to 0. And x is equal to 4. Now to finish the first derivative test, I have to look at what happens between each of these intervals. So I need to test values that are in between each of these pieces, because what I want to know is what is happening from -infinity to 0, what is happening between 0 and 4, and lastly, what is happening between 4 and infinity. The way that I do that is I go ahead and inside each of those functions, into my first derivative, I pick any value that I have inside that range. So -1 is in between and is included in the interval from -infinity to 0. The next interval I have goes from 0 to 4. You can pick any number you want inside this. I am just going to go ahead and choose this to be 1. And then the last one, I'm going to go ahead and inside my second derivative, I'm going to plug that value of 5. Now what I really want to know with these is this positive or negative inside each of these intervals? Not necessarily what the exact value is, but I'm really just looking at the positive and negative. So now what I'm going to go ahead and do is take these values that I've chosen, my -1, my 1, and my 5, and plug them back into my first derivative. So let's go ahead and plug those values in. So in the interval between -infinity and 0, I picked a random number and I plug in -1. When I do that, I'm going to get e to the 1. Now with the e, that's always going to be positive, so I don't really have to worry about that in each of these functions. The next part, I plug that -1 into the function, and I becomes -1 to the third power. And then again, plugging -1 gives me 1 plus 4, so this gives me a negative and then a positive. So what this tells me is that in the interval from -infinity to 0, the function of x will always be less than 0 because this will always be negative. Now the next one we're going to go ahead and do is f prime of 1. When I plug that in, again, that e to the 1 will always be a positive. That's 1 to the 3rd power. That will also be positive. And then 1 plus 4, which is will always be positive. So what that tells me is in that next interval from 0 to 4, my function will always be greater than 0. Excuse me, my derivative of my function will always be greater than 0. All right, so the last one that I have to do in here is a number larger than 4, a number that's in the interval from 4 to infinity. So when I plug that in, I'm just going to pick the number 5. That's e to the 5, 5 to the 3rd, and finally -5 plus 4. Now when I plug all of that in, so all of this will give me a positive times a positive times a negative. So what that tells me for this piece in the interval going from 4 to infinity, that first derivative of x will always be less than 0 or negative. Now let's go ahead and put that information back up into the graph that I have. So what this is saying here is that the first interval from -infinity to 0 is less than 0, so that's going to be negative inside this range. The next interval going from 0 to 4 is greater than 0, so inside this range it's going to be positive. And then the last one that I have going from 4 to infinity, that's always going to be less than 0, so that gives me another negative. Now, how does this interpret what the graph is going? Well, what happens is that the graph, when the function is negative, the graph of the derivative, it is decreasing. Then when it's positive for the next group inside here, it goes and the graph is increasing. And then finally, it comes back down and the graph is decreasing. So what that tells me is that my point at 0 is going to be a minimum value. My point at 4 is going to be a maximum value. All right, that's the end of the first derivative test. We're going to go ahead and now look at the second derivative test. All right, so I went ahead and wrote the first derivative down, and I wrote it in the form that we had before we factored it. And the reason that I did is I need to use the product rule. With this, I'm going to have to use a product rule twice. I'm going to have to use the product rule for the first part of the function, and then I'm going to have to combine it with the product rule here again for the second part of the function for the first derivative. All right, so for the first one, I'm going to let u is equal to negative e to the negative x, and the derivative of that is just the exact same thing, negative e to the negative x. We just have to always remember to multiply times the derivative of the exponent, which in this case is going to be a -1, which turns that into a positive e to the negative x. The next part with that is going to give me my v. My v is x to the 4th. v prime then is just 4x to the third. So I can put those two together for the first part of my second derivative. And the way I'm going to do that is I'm just going to take u times v prime, and that will go ahead and give me negative e to the negative x times 4x to the third. I add that to my next portion, which is my u prime times v, and when I do that, I am left with e to the negative x times x to the fourth. All right, now I'm going to go ahead and build the same thing, but now we're going to do that for the second part. So the second part, let u equal to be 4x to the third, and then u prime is just 12x squared. Next up, I have v, and v is just e to the negative x. The derivative is e to the negative x, the exact same thing, just we have to always remember to multiply times that derivative of the exponent. All right, I'm going to go ahead and combine those to the same way I did before, u times v prime, which goes ahead and gives me negative 4x to the third e to the negative x. And then the last piece that I need is my u prime times my v, and that gives me my plus 12x squared e to the negative x. Now there's a whole bunch of terms inside here. I would strongly recommend you go back and double check to make sure you have everything you need and your signs and all of those values at this point. Now this looks a lot worse than it actually is. The first thing I want to do with this is you will see that each and every one of these has an e to the negative x term in there. So let's go ahead and factor that out as a GCF. It's going to make this a lot more manageable when I do that. So I'm just going to take out e to the negative x. And when I do that, what we are left with inside here is negative 4x to the third plus x to the fourth plus 12x squared minus 4x to the third. And now this is much more manageable as a function. I want to go ahead and simplify inside here. I'm leaving this as e to the negative x, combining my like terms and writing in descending order, and I have that as x to the fourth minus 8x to the third plus 12x squared. And at this point you can probably see we have another GCF inside here as x squared. So I'm also going to go ahead and pull that out, and that's going to leave me with e to the negative x times x squared times x squared minus 8x plus 12. And at this point it's factorable, and it's a great thing when we're doing them like this and it's factorable because it means everything is just coming together. So this is still e to the negative x times x squared, and when I factor that, that gives me x minus 6 times x minus 2. We are now at a point where we can use the second derivative test. Where does the second derivative equal to 0? Well, that happens with each of the factors equal to 0. We talked about before how that e to the negative x can never equal to 0. So we have 3 more solutions here. We have that x could equal 0, we had x could equal 6, and x can equal 2. So that gives me my interval test that I need to set up for the second derivative. I have 0, 2, and 6. So in each side of this piece, what I'm looking for is what is happening from negative infinity to 0. What is it happening in this first interval? The way I do that is I take some value for f double prime of -1 and plug that in and test that. So I'm going to want to go ahead and test that, but I'm going to need a little bit more room in here for later. So I'm going to have my test point as f of -1. Over here in my next interval goes from 0 to 2. My test point inside there is going to be 1. My test point inside the interval from 2 to 6 is going to be 4. And lastly, my test point inside the interval from 6 to infinity is going to be 7. So I'm going to go ahead and do these on a different slide, and then we're going to come back to this range that we have here. So I'm taking all of these values and plugging them into my second derivative to see what is going on with all of that. So let's go ahead and plug that in. And remember, what we're really worried about this is if the value is going to be positive or negative. So as I plug this in for -1, again, 1 over e to the x, that's always going to be positive. Then -1 squared is always going to be a positive. -1 minus 6, that's always going to be a negative. And the last one, -1 minus 2, that's always going to be a negative. So that tells me that this is always going to be a positive for that first interval. Negative times negative is a positive. I do the same thing for the 1 for the next piece, and the first 1 over e to the x is always positive. 1 squared is always positive. Then I have 1 minus 6. I'm plugging it back up into here again. 1 minus 6, that is going to give me always a negative, and 1 minus 2 will also give me a negative value. So this is, again, always going to be positive. If I do the same thing for the 4, what I have here is 1 over e to the x. I'm going to write this one all out. Then I have 4 squared, so that's going to be positive, times a positive. And the next one is going to be 4 minus 6. That's going to give me a negative value. And then 4 minus 2, which is going to give me a positive value. So this interval will be a negative. The last interval I have to do is 7, so that's 1 over e to the x, which again is always positive. Then 7 squared, which is always positive. Then 7 minus 6, which is positive. And lastly, 7 minus 2, which is also positive. So now I have my interval pieces, so I'm going to go back and put those in. So this portion, the graph is increasing. This portion, the graph is decreasing. And then the graph is increasing again. So what that tells me is this portion of the graph that goes from negative infinity to 2 is concave up. The portion of the graph that goes from 2 to 6 that's decreasing, so from this portion it is concave down. And lastly, the last interval will be concave up. So I'm just going to go ahead and write that out just so you can see what that would look like. What that means is that from negative infinity to 2, I know this is concave up, and I can do that because even though I had 2 different intervals, it tells me that 0 is not going to be that point in inflection. I'm combining them, and that doesn't surprise me because 0, when I did the first derivative test, 0 was a minimum. The next interval that I can go ahead and talk about here as writing it out will be the interval that goes from 2 to 6, and that's concave down. And I can add on to this other interval. If you're going to union them, you would put both of them together with a union symbol, and that will go from 6 to positive infinity.